Let me see. Yes.
Yep, the recording is on.
Okay, over to you, William. I think I can mute and hand over officially to William.
Hello, can you hear me? Hello, Terence.
Yes, on my end I can.
Okay.
And I
Great.
suppose.
Loud and
Thank
clear.
you.
Carry on, William.
Thank you, Pauline, for the thumbs up. Okay. Terence has done like an elaborate introduction on who I am as a person. I'm William Koyani, an AWS community builder, as well as an AWS instructor. And I'm glad to be with you in today's session. So I think we can start. I've met a few people around, likes of I think Jacob, Isaac. The rest are a bit new to me. That's Felix, Harriet, Raphael, Olu, and Eluasu. It's great seeing you in today's session. So for today's session, we're going to be covering topics that are more or less related to AWS Compute as a whole. And if you have any questions, please feel free to just post them on the chat, or you can raise your hand and you can ask your question if something is not clear. So I think it's fair enough to begin the session. It will be a relatively short session since there are just around 3 topics that you have to cover with a few demos that we'll have to touch on today's session. My network is a bit bad, so you'll allow me to just turn off my camera so that I can be able to conserve my bandwidth. Okay. So what you're going to be covering in today's session will be focused on AWS Elastic Beanstalk, AWS Lambda, and AWS Batch. And just before we begin with the first topic of the day, I'll want to know anyone with an idea of the topics that you're covering in today's session, Beanstalk, Lambda, and Batch. Just a one on the chat to let me know. Anyone? And do you have access to the chat? You can post a one on the chat if you're familiar with the likes of Beanstalk, AWS Lambda, and AWS Batch as a service. A one on the chat will do, 0 if it's relatively new to you. Thank you, Isaac. Yeah, Jacob. We have a one from Jacob Gibson, Felix Kuria, Harriet. It's also one. Nice. Great. The rest of the team, you can post if it's a 0, if the topics are a bit relatively new to you, for the ones that you're going to be covering. Thank you, Felix, too. So we'll start with a scenario, and in our scenario, we'll be trying to understand what service is this that you're going to be dealing with in today's session. So a startup is trying to build a web application for online job listings. probably you might think of one of online job listings applications that you can get to interact with is probably Work. Is it Workday? Is one that you get to interact with. They need a fast and easy way to deploy, manage, and scale their applications while focusing on development rather than infrastructure management. Anyone with an idea what this service might be? It's a startup that is trying to build a web application for online job listings, and they want a fast and easy way to deploy and manage their applications while focusing on development. Thank you, Jacob. Jacob says AWS Beanstalk. Nice. Yeah. Focusing more on development rather than infrastructure management. And one service that solves this problem for us is AWS Elastic Beanstalk, as Jacob and Elasu has mentioned on the chat. So with Beanstalk as a service on AWS, mainly it allows you to provision and operate your infrastructure without the need of having to manage the underlying infrastructure you as a customer who is using it. So what you basically do is that you provision your code. You as the user or as the developer, you just provision your code on the Elastic Beanstalk, and then Beanstalk worries about now providing the necessary infrastructure configurations that are going to manage your application based on the code that you have actually provided. So you get probably the HTTP server, the application server. Let's say probably it's going to be an EC2 instance, the language interpreter, the OS that is going to be operating on your application, and even the host that you have. So everything is created behind the hood, and you don't have to worry about let's say, when you want to deploy a web application, let's say, for example, the one which is you've mentioned from the previous slide. Well, we mentioned from the previous slides, we have what is it? A job listing. We have a job listing app. So there are two options that you might find at times that you might opt to go for. If probably you're a hardcore engineer, you might decide, okay, let me host my web app on probably an EC2 instance. So you'll have your web application probably on an EC2 instance. What else would you need for your application? You might decide, let's say, if there are two servers that you're going to be provisioning, you might actually need probably a load balancer to balance the load of the traffic that is coming to your application. And in the event you're going to be experiencing high traffic on your application, probably you might decide, okay, let me also include an auto scaling group to be able to scale automatically, and any other thing that you might need for your web application. Anyone with an idea, probably you can just post it on the chat, or you can unmute and speak. If you're deploying a web application, what are some of the things you might need? I know you might need some servers to host your application, like a web server, and that's where EC2 comes into place. Yeah, a CDN. Yeah, thank you, Jacob. CDN is also another one. So you might also need a content delivery network, just to ensure that your customers are having like the best experiences when they're accessing your application. Anything else? In the event, let's say your customers are going to be logging on your application, you want to be able to store their login details. So what else would you need? I can see Felix Kuria typing on the chat. Felix. S3 for storage, yeah. You might need S3 for storage of your static content. Thank you. Let me add that here. Yeah, probably you might need S3 for storage. Thank you. This is nice. Security using Route 53 and WAF for HTTPS. Yeah, thank you. Thank you so much, Jacob. Yeah, that's also something else you might need if you want to. Yeah, Route 53 for, yeah, and also WAF. Awesome. So you notice that all these configurations that you might be doing yourself in the event, let's say you don't have Elastic Beanstalk. So you might decide, okay, I'll provision an EC2 instance to host my web server. I'll have to configure some bit of load balancers to ensure that traffic is actually being distributed to different targets without having one point of bottleneck. You might decide, let me also have auto scaling just to ensure that there's that automatic scaling in the event there are huge traffics coming to my application. And what Felix has also mentioned on the chat, you might also need S3 storage for probably static content that you want, and also some bit of CDN to improve the performance or the experience of your customers who are accessing this job listing application that you have provided for them here, and also some bit of Route 53 and WAF for security purposes. So these are configurations that you're doing manually yourself. But let's say you're a developer who has no idea how to go about managing an EC2 instance, a load balancer. You don't know how even to configure a load balancer, an auto scaling group, and also probably an S3. These are things that probably are relatively new to you as a user. And you just want a service that is quick and will provision all the resources for you without the need of having to manage the underlying infrastructure. So this is where you get Elastic Beanstalk comes into play, and you can see that it performs for you automatically, scales your applications up and down based on your how your customers are actually accessing your application. So it does like provision everything that you're required to have within your application. If you look at some of the components that you might get within an Elastic Beanstalk environment, we have two types of environments that we're going to be talking of. One is the web server environment. And with the web server environment, this is where probably you're going to host your web application. So it provides you with the necessary AWS resources. It provides you with a unique name, and also you can also use your own like a domain name. We're going to see this in a few minutes with just a short demo that is going to showcase for us when you're using the web server environment to provision our application. So you get a domain for your application, and you can quickly access this application using the domain. It provisions for you different EC2 instances. You can have one EC2 instance or even multiple EC2 instances with some bit of load balancing. You see what we were talking of on the whiteboard, provisions and elastic load balancer, some servers to host your applications, and with some bit of auto scaling integrated to it. Jacob mentioned on security, you get like a Route 53 where your domain name is actually registered. So you see you already have a domain name that is registered for you that you can be able to use within the Route 53 as a service. Also, you can configure some bit of monitoring to be also to be able to get alerts in the event anything is happening on your resources. You also want to log some of the events that are happening on your resources. Let's say you want to be able to scale using the auto scaling tool. You have configured some bit of metrics. So we have probably CloudWatch that is doing the monitoring for you. And then it's able to scale your application based on the alerts that you've set. For instance, you might say if the CPU utilization gets to around 80%, please provision for me more EC2 instances that I can be able to make use of for my application. So in our job listing application, probably during the beginning of the year, people are looking to transition to new jobs. You might find that we have a lot of customers who are trying to access your job listing application, sending application, looking for jobs that might suit them. During that time, you might want to be able to get those alerts and just scale your application based on the needs that you're getting from the customers. So with Elastic Beanstalk, we have two types of environments that you can have. We have the web server environment where you host your web application. Uh, and the other environment that you get to see is the worker environment. So with the worker environment, easy, at least a bit. We have the work environment. It's in the event, let's say you have within your web server environment or web tier, there's some bit of processing or extra processing that your application is going to be doing. So you might want to be able to integrate with the worker environment. This is probably in the event, let's say you're going to deploy your application in the production environment. So you might integrate it with services like SQSQ to queue some messages for further processing. You want to be able to check, for instance, where we've said we've started with our job listing. With our job listing app. So within our job listing app, we want to be able to get some extra processings that are done to be able to check what jobs are people applying for more in the market, or what jobs are people looking for more to transition into, what roles are people actually looking out for more. Is it entry level? So is it entry level roles? Is it managerial roles, executive roles? So those are some of the things that you might want to get more information about within your application. So you might decide to integrate it with other services that are able to do that for you. So that's how you get you introduce like a worker environment to just have extra processings that are actually done. We'll see this within our demo for today's session. But up to there, anyone with a question related to Elastic Beanstalk? Okay, seems good. Yes,
I don't see the
Felix.
question in the chat, so I think we are good to proceed.
Yeah. Okay, I can see Felix Courier typing, so probably can wait for the question. So go straight ahead with our demo on Elastic Beanstalk. And let me ask this question before we continue. Beanstalk as a service, under the service models, where does it fall? AWS service models. Thank you, Jacob. Yeah, platform as a service. Thank you. Yeah. So Beanstalk 8 is you can get it within your recently accessed services if you go on the AWS management console. But what's the work environment and the web environment? I haven't understood the difference. Yeah, we'll explain the difference with the demo, Felix. I think that will make clear difference between our work environment and the web environment. Elasu, yeah, please go on. Is it Elasu? You're unmuted, but I can't hear you.
Hear me?
Yeah, go on,
Okay.
please. Yeah.
Yeah, just out of curiosity, yeah.
Yes. You're muted, please.
Yeah, so I wasn't able to see the questions coming into the chat. So yeah, just out of curiosity, yeah. But now I can see them. I think I had an issue with my network here.
Okay.
Okay.
So Beanstalk as a service, you can always find it under the compute services. This way you can find Beanstalk. You access it from here, which is Elastic Beanstalk, and it allows you to do end-to-end web application management. So you can easily deploy your web application in just minutes. And something else I did not capture within the slides, but you can get to see it within the AWS management console. So with Beanstalk, it supports different languages. You can have Java, .NET, PHP, Node.js, Python, Ruby, Go, and even Docker applications on familiar servers such as Apache, Nginx, or even Passenger IIS. So those are the different platforms that are all the different languages that it might support. So we'll just click on create our application, and I think this is where Felix Gray you can get clearly like the difference between the different environment tiers that are there. So with Beanstalk, there are two types of environment tiers. We've been able to mention we have the web environment and the work environment. With the web server environment, just it runs your web applications or web APIs that basically they serve the HTTP requests that you have. In this case, we're going to be creating a web server environment since we are going to be serving some bit of HTTP requests for our web application and be able to access it via the HTTP. When it comes to the worker environment, it allows you to run applications that process long-running workloads on demand or perform tasks on schedule. Let's say you want to do further processing of requests that actually come on your application. So you might want to be able to do some bit of analysis probably. So you might integrate it with a worker environment that does long running workloads on demand or performs tasks based on the schedule that you've indicated. So we'll create a web server environment since you're going to be serving a HTTP, like we'll have a website on top of Beanstalk. Yes, I think this is Elsa. The last,
Yeah.
yeah.
Oh yeah, William. The name is Elasu.
Elasu, thank you.
But you can also say Elazu. I know some people the S is red, so it's alright. Yeah, so
Okay, yes.
I'm suffering a little bit, yeah.
Okay.
I'm failing to understand this worker environment. Could you probably give a few examples of the worker environment? The web server environment seems really straightforward and very clear, but then the worker environment is still punishing my brain. Okay, thank you.
Okay, thank you. Awesome. I saw a couple of ones on the chat when we were starting the session. Jacob said he has a fair idea with what's going on with the topics that you're covering. Jacob, sorry for putting you on the spot. Probably, will you want to weigh in on the work environment if you have an idea?
Okay, so maybe I can use a very simple example.
Okay.
Let's take an example of like a payment service. So let's say an order has come in, and we need to verify the payment. So there could be a worker environment that verifies payments that has come in before the order can be confirmed. So that's where I would create a worker environment to do the validation of the payment. I don't know if that answers Elasu.
Yeah. Elasu, does that answer your question? Thank you. Awesome,
Make,
Jacob.
makes sense. Thank you, Jacob. Now
Yeah.
you make part of my brain, yeah?
Awesome. Thank you. Yeah. So in the event you want to do like further processing, most use cases and I believe Jacob has given like a good example of payment service, or you want to do send emails and you want your customers to be getting those notifications, or you want to be handling queue tasks for your web application, might decide to do that. At times, probably let's use also another analogy that you can get. For example, you're doing ordering foodstuffs online, and it's an order application. Like which applications can you order? Like Glovo. Uh, it's one that you can find that it's within the worker environment for further processing of the queues within your web application. So we're going to create a web server environment just to showcase how you can be able to go about having a website on top of Elastic Beanstalk. So we'll name it as our give it a name, trying to find the name. So this is our XYZ app. So the environment information is going to be provided here as environment name XYZ app. For the domain name, this is going to be provided by Elastic Beanstalk, so it's going to provision all that for us. So we are not going to be defining anything here. We leave it as blank. It's going to be auto-generated by Beanstalk. The platform will go with a managed platform that's published and maintained by Elastic Beanstalk, and we'll select the platform that you want. So the different platforms that it supports, and these are the different languages that you might find yourself working with. Probably .NET Core on Linux, .NET Core on Windows Server. We have Docker, Go, Java, Node.js, PHP, Python, Ruby, and also Tomcat. But in this case, we'll just go with Python, and we'll select Python 3.3 as the runtime, and the platform version we're going with a 4.4, the one that is recommended for us. For the application code, we'll just use a sample code that is provided by AWS. So we're going to, but if you have your own code running locally on your machine, you might decide to upload it. The different source codes that you can have. It can be on your local machine, like local files, or even public URLs. You have uploaded it on an S3 bucket. You can always put your S3 bucket URL here, and then it's going to pick it from there. Right? We'll just pick a sample code. The presets, you can decide to go with different configuration. Let's say if you want to go with a single instance, which is free eligible, or you want to go with a single instance using spot instance. And in the event you going for single instances, probably these are workloads that can actually withstand some bit of interruptions in between. So you will opt to go for a spot instance and also get the discount that comes with using spot instances on the AWS, which is 90% of the on-demand instances. If your application, you want to ensure that you're maintaining high availability for your application, you can decide to go with a high availability, or you can choose high availability with spot and on-demand instances, or just a custom configuration. When in our case, we just go with a single instance just to showcase how it actually works under free tier eligible. So I'll just click on next. Configure service access, and this is really important. If you actually miss this bit, your application might not actually reflect. So in this case, in the service access, it's basically IAM roles that assumed by AWS Beanstalk as a service. Yeah, we're going to be creating like a service role that will allow us, and also an EC2 instance profile role that will allow Elastic Beanstalk to create and manage our environment for us, since it's going to be using other services in the background to launch other services in the background for us. That's why we need to create some bit of service role and an EC2 instance profile role. So in this case, we'll just go with use an existing service role. In this case, we have an Elastic EC2 Elastic Beanstalk service role, and we're going to also be using the EC2 Elastic Beanstalk role, which is also an EC2 instance profile role. For the key pairs, we'll just leave it as a default. But if you don't have this roles defined, you can always create new ones for yourself. But at times, mainly you might find the one that comes like auto-generated for you, it's probably the Elastic Beanstalk service role, but we'll go with just the ones that we have at the moment. In the event you're going to be having, let's say, data that you want to be stored within your application, like a database, might decide to configure some bit of database configurations, instance traffic scaling, and also some bit to configure like updates and monitoring. But we're going to be skipping all this, which are a bit of optional details for the demo, so that you just see how it quickly deploys our application and can have it up and running. So we'll just skip to review. And we can see the environment information. It's a web server environment, the application, it's the XYZ app, and they're using a sample code, which is a sample Python code that you're running, Python 3.3, that we have service access. We have two roles that we have actually defined: Elastic Beanstalk service role, and EC2 instance profile role that we have. For the rest of the configurations, which are a bit optional, decided to actually skip them for now, which is the networking, the database, instance traffic and scaling. It's going to be doing that for us. Also some bit of updates and monitoring. But these are things you might decide to do yourself as a customer, configure them within your Elastic Beanstalk environment. What I'll do, I'll just submit this. It will take a few minutes to actually provision for us the environment. So in the meantime, what you can do is just go under events. If you see under events, we can try and look at some of the events that will be happening here. So it just started the creation of the environment for us, and we'll see some of the resources that will be created within this. So if you look under events, create environment has started. Elastic Beanstalk has started creating like an S3 bucket. So we have an S3 bucket here, which will be hosting the environment data. We also have a security group that is being created on our behalf. This is probably for the access of our application that we will be having. We also have an Elastic IP that is being provisioned for us under events. You can be able to see that here. So once the environment has been provisioned, you're going to get a domain here. It's the domain that you're going to use to access our XYZ application that we have actually created here. It also does perform some bit of health check. If anything fails in the event you're going to be provisioning your environment, it's going to be indicated here. So you might be able to just see under health also here. There's just probably an EC2 instance that failed to launch. It will be indicated under events. We also have monitoring, but you remember we did not configure anything related to monitoring, and also alarms, and same with the managed updates. So let's go to EC2. Show you some EC2. So if you go under the EC2 management console or dashboard, if I click on instances, you can see we have our, let's look at the ones that are running at the moment. We have our XYZ EC2 instance that has already been provisioned for us, and it's actually running. We did not have to come to the EC2 management console and actually create this. This has already been done for us using the Elastic Beanstalk environment that you have actually provisioned. If I click on it and look at the different configurations that are there under security, we'll see that there's a security group that has already been created. It is the one that was actually defined within the environment that we launched. So this is the security group, and it has some bit of inbound rules on port 80, since you're going to have like a web server on it. Outbound rules, it allows all outbound rules. So we can go back to Beanstalk, or we can just do this. Let's do cloud formation. So under cloud formation, you can see we have a stack that was created for us. So probably you might be asking yourself, what happens when we put our code on Elastic Beanstalk and it quickly just provisions the resources that you want? So behind behind the hood, Beanstalk makes use of CloudFormation to actually deploy the resources for us. So if you look at this stack that is here, that was actually created, uh, let's look at the template. Uh, just a minute. So it made use of these templates to deploy all the resources that we want. Description, we have like an EC2 instance that was actually provisioned for us. Within the web server environment, anything else that you can try and see. Let's just make use of Vite in Composer so that we have a visual representation. Yeah. So, if you look at the visual representation of what the resources are being deployed within the Elastic Beanstalk, it actually did launch for us like an auto-scaling launch configuration that contains some bit of a security group and also an auto-scaling launch configuration that was used. It did provision for us like an Elastic IP that was provisioned in that case. We have some bit of Elastic Beanstalk metadata that were actually provisioned for us. And within this launch configuration, this is where you actually get the EC2 instance that was created for us. We also have some bit of conditions that were there that were created. So all this was done using the CloudFormation template that was able to define all the resources that you might have needed within the code that you provided for Beanstalk. So we can go back to Elastic Beanstalk. The environment has already been created, is actually okay. So you can click on it and click on this domain and you can view our application. I see we have our application up and running and it says, congratulations, your first Elastic Beanstalk Python application is now running on a dedicated environment in the AWS cloud. With all the configurations that you have actually needed. So you can deploy like a Django application or even a Flask application on Elastic Beanstalk. We do not need to create any EC2 instances to host our application. We just provided our code and the rest we left it to Elastic Beanstalk to deploy for us our application. If I refresh this, you might see it's actually loading as fast as possible. The domain is actually registered under Route 53 within the architecture that we saw previously. And it's also configured with a bit of a CDN. That's why there are no lags when you're actually refreshing the application. So this is like the quickest way you can have your web apps running on Elastic Beanstalk. And we saw some things, some of the configurations and the details that were created for us. We saw it made use of a CloudFormation template. If you look at the resources here, We had an auto-scaling group, an auto-scaling group launch configuration, elastic beanstalk metadata that was defined, an elastic IP, a launch rate, and also some security groups that were also created. If you go under S3, we saw that it actually created an S3 bucket for us. Might be able to see the S3 bucket that was created on our behalf. Think this one. So we have an S3 bucket that was actually created that contains all the applications data. All this we did not have to come to the S3 management console and do all those configurations ourselves. Beanstalk was able to do that for us and provision the resources that we need for our application. So that's it on the demo. On Elastic Beanstalk, we have a sample application which is already running on Beanstalk with the necessary configurations with auto scaling configured and also load balancing configured on top of it. I think we can go on with the next part of the slides. So any questions up to there? Okay, none. So do another scenario, and this will introduce our next topic of the day. So you have a social media platform wants to allow users to upload profile pictures. When a user uploads an image, it must be resized and optimized before storing it in Amazon S3 buckets. Nice. What service will allow us to do this on the AWS management console? Thank you. Thank you, Zico. Yeah. AWS Lambda. So if you look at what it says, the user uploads an image, the image must be resized and optimized before storing it in an Amazon S3 bucket. So Lambda actually solves that problem for us. So we have AWS Lambda, and AWS Lambda is a serverless service on the AWS management console, and it falls under compute. And what do you mean by serverless? What do you mean by serverless? Sophia? I see Felix typing on the chat. What does serverless mean? AWS takes care of everything infrastructure. Nice. Okay. Thank you, Felix. Harriet is also typing on the chat. Let me wait for this comment. No infrastructure maintenance. Nice. Yeah. Infrastructure maintenance. Are the servers there when you say serverless? Or the servers are not there? No infrastructure maintenance. Thank you. So with serverless, basically it means AWS handles the underlying server infrastructure. Thank you, Isaac. So with serverless, the servers are there, but then the responsibility responsibility of actually managing or maintaining the infrastructure, the underlying all the servers, like doing the server patching, security patches, updates on it. That's not your responsibility. AWS actually takes care of that, which has been highlighted by Isaac on the chart. AWS handles the underlying server infrastructure. AWS takes care of everything infrastructure. Thank you, friends. Yeah. So this falls under serverless compute, and AWS handles everything else related to updating and security patches that are related to AWS Lambda, it being a serverless service. It supports a variety of languages. It have Node.js, Java, Python, C#, Go, PowerShell, Ruby, and even more. We'll be seeing this more as we go on. The runtime is up to around 15 minutes. We'll also see, can it be less than that? So we'll also be talking about that. And it supports up to 10 gig of memory. Lambda is an event-driven service. It's triggered based on different events that are happening within your application or event services that you have. So it's invoked. That's what you're seeing on the architecture here. We have the event source and the optimal response that you get from Lambda. Previously, Lambda was called Function as a Service, FAS. But this was actually changed. So that's why we say Lambda is a serverless compute service, and it's an event-driven service. Function, because mainly you just provision your function code, and then Lambda handles the rest for you. So the event source, it triggers the AWS Lambda, and then Lambda is able to perform the different actions based on the function code that you've actually provided. It can either be a function code in Python or even the likes of Java, or even C# as a different function code that you have. You can integrate it with different services to perform different actions that you want. For example, image processing that you've been able to mention in our previous scenario. So in the event, let's say someone puts an object in puts an object in Amazon S3. Here is where we have our S3 bucket. In the event someone puts an object in Amazon S3, you want your Lambda to be invoked to be able to process the image and probably be able to get some bit of thumbnails out of it. So based on the function code that you have actually written, Lambda is able to process the images and actually generate those thumbnails and store them within the different locations that you might want within your AWS services. In this case, probably you want to store them in still Amazon S3 as a bucket, might want to do that. There are different event sources that you can get. You can have the likes of DynamoDB as an event source, AWS Commit, Amazon as a simple email service, SQS, SNS, Event Bridge as well, CloudTrail, even the likes of Amazon CloudWatch, even the likes of CloudFormation, and even step functions. You can always integrate them as the event sources for your Lambda function. Even an S3 bucket, the one that you've explained, where if someone puts an image in your S3 bucket, it's able to process that image and also generate thumbnails for you. So that would be one. Or even some bit of IoT services that you might want to integrate, or even the likes of Amazon, Alexa, Compute, API gateway, load balancers, and the likes of Kybase. Those are the different event sources that you can get for your Lambda functions. When it comes to the Lambda function anatomy, how it's actually built, this is an example of a Lambda function and how it actually looks. So we have the function handler and the event object and the context object. With handler function, just the function that's to be able to run upon invocation that you have actually defined here based on the event, like the data sent during the Lambda function invocation that you might get. The context, this is the method available to interact with the runtime, like the request ID, the log group, and even more that you can get. We'll see this with a demo that will be able to show us how Lambda actually works. So we have AWS Lambda. Change this. So Lambda lets you run code without thinking about servers. That's why we said it's serverless. With Lambda, you pay for only the compute time that you consume, and there are no charges when your code is not running. So this is the beauty of actually making use of Lambda as a compute resource on AWS. So with Lambda, you can run your codes virtually, any type of application or backend services with all zero administration. You just need to provision your functions of Lambda. We've said it supports a variety of languages. How it actually works, we have the likes of .NET, Java, Node.js, Python, Ruby, and even custom runtime if you want to configure custom runtimes for yourself. But we can look at Python, and this is just a hello world. It runs for you hello world Lambda function. So the Lambda handler, the event, and the context. So we can run this and see how it actually works. Hello, hello. You can see it actually produces for us hello from Lambda, which is the event we've actually created. Next, we can view how the events actually happen and the different sources that you can get for your events. So you can have probably a mobile application, streaming analytics, cameras, all generating different events, or even a mobile or IoT backend or data processing, and it scales automatically. And at the moment, you can only see there are only 2 servers that are working for us. But let's see if we increase the amount of traffic that is going to AWS Lambda, and you see how it actually works. So you can see continuous provisioning more servers to be able to handle the workload that we have at the moment based on the different event sources that you're providing at the moment. So it scales automatically for us to be able to handle the traffic that we have based on the demand. You start incurring cost once you surpass 1 million requests or 1 million invocations. So at the moment, you can see it's at 0, but if you continue doing more invocations and it gets to around 1 million, now it starts incurring a cost with Lambda. We can create our own function and just see some of the configurations that we get from using Lambda. You can decide to author it from scratch if you're okay with or you're good with your coding, like Python, or the different languages that you're familiar with. You can always author it from scratch, or you can decide to go with a blueprint or even a container image to deploy your function. But in this case, we just go with a blueprint that is actually provided with a sample code from AWS. The blueprint, we're going to select a hello world function. And in this case, we're going to pick Python as our hello world function. Then we name it as our demo CSC function. We have an execution role. You can choose to define the permission of your function. This is in the event Lambda is going to be triggering other services. That's why we have like an execution role that is highlighted there. Here's our code and how it actually looks. The sample code, the Lambda, which is a function, the def function here. We have the Lambda handler, the event, and the context. It's just going to print for us value 1 based on the event that you're going to. So I'll click on create function. Hello, Mark. Function has been successfully created, so you can decide to test it and see how it actually looks. If you want to edit how the function looks and how it performs some of the actions for us, you can come here under the code and make some bit of editing here. But you're not going to be editing it, so we'll just leave it at default. So we can test it and see if it's working correctly. My demo friends. Template hello world, and it's just going to print for us value 1 for us based on the event JSON that is there. So I'll save this and then click on test. The execution function succeeded. So if you look at the details here, you can see the execution time. It took 1 second, like 11 seconds ago. Initiation took like 74.52 milliseconds. The building duration, your build when your function actually runs. So the building duration is 12 milliseconds. That's the only time that you're going to be built for your function. Memory, maximum memory allocation for this function was 31 MB, but you'll be looking at some of these configurations that are there. Anything else that you need to look at? If you look at the function, it was able to load for us value 1, value 2, based on the event JSON that was provided. Build duration, you said it's 12 milliseconds. Memory size is 128 MB, but the maximum was actually 31 MB. It was there. So you'll only be built for this time that your function was actually running. If it was not running, you're not built for that. So you're only going to pay for 12 milliseconds for when your function was actually running. Other configurations that you can try and see under configuration, we can look at the memory allocation. Let's click on edit. So in terms of memory, you get up to, we say it's around 10 gig of memory, but it can be as low as 128 MB. and 10 gig of memory. So you can always increase the memory size of the function allocation that you want to configure. The default runtime, it can run up to 15 minutes. It's like the maximum that you get. Maximum timeout is around 15 minutes that you get. I think these are like the main things you need to capture: the memory allocation, the runtime. It's actually 15 minutes, and then it times out. So in some use cases, you might get questions that are asking if it runs beyond, let's say, past 30, like for around 30 minutes, you might not need to have a Lambda function, because the Lambda function, the default or the maximum is actually 15 minutes. So you might not need to configure a Lambda function. So I can't do that. I think that's all on Lambda, other function, other serverless service on AWS. So our next service, yes, Jacob, please go ahead.
Yeah, I just wanted to add a compliment around the custom runtimes that we can use for the custom runtimes can be Docker containers, because that one can support any type of OS or whatever you want to use that is not supported natively by Lambda.
Yeah, thank you. Thank you, Jacob, for that. Awesome. So into our next slide, and we've been using scenarios just to understand some of these services that we are running. And for this case, we have a scenario with us, and we have a biotech company is conducting DNA sequencing. It needs to process thousands of genomic files to identify mutations across different samples. The workloads involve running computational expensive bioinformatic tools. So what service can be able to solve for us this problem based on the scenario that we have? Any ideas? It has, like, the main thing you should be able to capture, it has like thousands of genomic files. Yeah, AWS parts. Thank you, Jacob. To identify mutations across different samples, and involves like running computational, like expensive bioinformatic tools that will be running on top of our biotech. So this will introduce us to AWS Batch. And with AWS Batch, it might look similar to, in a way, to AWS Lambda, which I've actually covered from the previous slide. But it's a fully managed service that enables you to enables efficient batch processing at any scale. So it dynamically provisions compute resources based on job demand. And some of the batch jobs that you might find yourself running are processes that have a definite start and end time. Let's say like daily reports to your executives. Those are examples of batch jobs that you might find yourself running. So a batch job is just a job that starts and ends as opposed to continuous. So that's why you have a service on AWS called AWS Batch. It supports integration with AWS services, the likes of Amazon S3. Will be seeing a good architecture related to how it supports Amazon S3. We have EC2 Fargate, and Fargate is in relation to using Docker images that run on ECS. So you can be able to use it there and support instances. Batch jobs are actually defined as Docker images, and they can run on Amazon ECS, which is a container service for AWS. Some bit of just understanding the architecture when it comes to AWS batch. Some of the components, like the main components you should be able to capture, it's the job definition, which basically specifies like a containerized workload, and you have said that it uses Docker images on top of ECS, where you can define the jobs. We have job queues that holds like the submitted jobs. And then we have the compute environment, which autoscales the EC2 instances or the Fargate instances. So in the event you're actually going to be deploying your Docker images on top of ECS, you might decide to go with two options. That's why you're seeing it autoscales EC2 or even Fargate instances. When launching your, or while defining your task on the ECS, you might find you can decide to go with EC2 launch type, or you can decide to go with a Fargate. I think launch is written that you launch type. You can decide to go with these two. So with EC2 launch type, you're the one who's actually going to be managing the cluster of EC2 instances that are running on top of ECS. But when it comes to Fargate launch type, this is like a serverless offering. So you don't have to worry about the scaling. So it does like auto scaling for you. Yeah, so that's why you're saying with compute environment, you have it auto scales the EC2 instances, or the Fargate instances that you have on ECS. Then we have a scheduler. Basically, what it does is dispatch the jobs to available resources that you get. We have a flow that will be able to showcase the architecture of what actually happens. You can upload an image on Amazon S3, then AWS batch queues use it to be able to perform some parallel processing, and then that's actually stored on Amazon S3 bucket. So good architecture is the one that you see based on the flow that we have looked at here. So you upload your image in an Amazon S3 bucket. Then what happens, it's able to trigger AWS batch based on the container image that you define, either between your EC2 instances or the spot instances that you have within your ECS Elastic Container Service. So batch is able to do the parallel processing of the image, and then the results are actually posted on an Amazon S3 bucket. And you'll see batch, these are jobs that have a definite start and end time that you can be able to run with AWS. Good example, it's reports or data analysis reports down the main types of batch jobs that you might get, you might want to run on EC2 instances. If you want to save on cost, you can decide to go with spot instances, which offers you 90% of on-demand discount of on-demand instances, and you get to save on cost of that. So that's all on AWS batch. I did not have any demo dedicated to batch, for today's session. Yeah. So I don't know if there are any questions. Any questions are related to what you've just covered on AWS batch, beanstalk, and Lambda?
I don't have any question from my end. Let me just check in the chat room.
Okay.
No question in the chat box as of now. So I guess we can proceed.
Okay. So in the event of no any other questions, I think this is where my session ends for today. I know it's a relatively short session, 3 services, Beanstalk, Batch, and AWS Lambda. I hope you gathered a lot from the services. You can keep on practicing. I feel always suggest the best way to keep on improving on AWS is looking at their documentations. So there are some tutorials you can always get. Let me share this with you. There are some tutorials you can always get that you can make use of to practice. So the likes of AWS Patch as a service. We have some getting started tutorials getting started with an EC2 instance, orchestration. You can come here. If you have an AWS account, just go through this tutorial end to end up to create a job definition, and then once you're done, you can always terminate some of these resources. It's also a good resource when it comes to basically understanding how these services work. With the documentation, they provide like a comprehensive guide. We have the AWS Patch dashboard with some bit of tutorials where you can add a single queue widget on AWS Patch dashboard. You can make use of it to just learn more on how to practice with AWS Patch. So I think I can share this documentation links on the chat so that you take time to practice. That's all from my end. Thank you so much for being amazing students, sitting through the session. I think that's all from my end, Isaac.
All right. Thank you so much, William, for your continued support to our community. And as usual, we look forward to having you come back to talk to us during the course of this boot camp.
Sure.
Great. So I think now we can hand over to Pauline, if she's on the call.
I don't know if Pauline is.
Do we need
Because I
a
know she was
break, like a
experiencing.
10-minute break, Isaac?
Yeah, sure. That's fine. So it's 11:20. We can reconvene at 11:30.
Sure. Okay, so we'll take a 10-minute break. 11:30, we will have Paulina.
All right. Okay, cool.
Okay, thank you so much, William. And guys, you can take a bio break. Get yourself a glass of water. I'm a Kenyan, so I've got myself a mug of tea and refreshed. and then we get back to completing compute with Pauline. I think she'll be leading us through EC2 autoscaling, elastic load balancing, and I think she'll wind up with AWS outposts. So let's take a 10-minute break, and then at past we'll be back to complete the session. Huh?
All right.
Okay, bye bye. See you.
Hello, everyone, parents.
Hi, Pauline. How are you?
How are you?
Great, great. I think let's give like some more 2 minutes to the members to get on. Then we can kick off.
Perfect.
All right.
Okay. Hi, everyone. Yeah, I am so happy today. It's Saturday. I hope you're all
Pauline,
having the energy I have.
Pauline, why are you happy? You have to tell us your secret. Why are you happy today?
It's weekend.
Oh, okay. Okay. Oh, okay. I guess it.
Yeah, we get to rest a little bit. I don't know, but I just woke up happy, so I can't put anything to it. Hopefully, I can what is it? Pass this energy through osmosis to you all, or load balance it. Anyway, let me wait for the rest. Hi, Jacob. How are you doing?
Hi, Paulina. Probably did not deploy anything on Friday. That's why.
No, we don't push anything to production on Friday.
Yes.
We don't do that. Yeah, so we push all our problems to Monday.
Yeah. All right.
Let me see. Hi, Felix, Oscar. Nice to meet you all. Hi, Harriet. Hi, Elaso. I hope you're all doing well. For the rest, I know them. No need to tell them hi. Okay, Isaac. Whenever you're ready, let me know.
I think we are ready. We can get on. Other members will get us along the way. Over to you.
Okay, and awesome. Thank you, Felix. Let me go ahead and share my screen. And let me know once my screen is visible.
Yes, it is.
Perfect. Perfect. Okay, cool. So William started us with compute this morning, covering some aspects about Beanstalk, Lambda, Batch, and so on. But I want us to take us back a little bit. So my focus on today's training will be more on high availability and scalability with regards to compute. So EC2 in AWS. Some of these content, let me say, majority of the content we are familiar with for those who went through the Cloud Practitioner Bootcamp. But I might be touching on some of the aspects that if you're preparing for the Cloud Solutions Architect exam, you might need to know about. So I'll just start from the foundation. We are doing like a recap on what we know about high availability and scalability, how to set up that, and hopefully at the end, when we get some time, we'll just dive into a demo, see how we set up all these processes in AWS. So yeah, don't be worried when you see I'm starting from high availability. So we just start from the beginning aspect of it, and then we dive deeper into now as a solutions architect, how do you architect this stuff in the cloud? And what extra thing you need to know, especially for the solutions architect exam. So I'm excited, and before I get started, maybe just make it interactive. What is the difference between high availability and scalability? And I'm going to add more to it, and elasticity. Or let me start with, what is the difference between scalability and elasticity? And then we bring in high availability later with respect to AWS. So elasticity versus scalability, how do you understand the difference? Anyone, you can unmute, you can, yeah, Jacob, you can come in, you can put on the chat what you think.
Okay. So I think I would define the elasticity as the opportunity to be able to increase or decrease the number of servers. For example, if we are looking at EC2 instance, then scalability would be to do with the resources that you have. For example, if there is maybe high spike of like high spike of traffic, then I can be able to handle that strike. That means that there is enough resources that can be able to handle that.
Okay, I love that.
Yeah.
So kind of spot on. But I will also give my perspective of it in regards to we talk about elasticity and scalability. Also with regards to the exam, because the exam also confuses us a little bit in terms of AWS. So that is scalability, elasticity. What about high availability? What is it? And how is it related to scalability or elasticity? Okay, Jacob again. I
Yeah.
encourage the rest to also come in.
Yeah, so high availability is ensuring that your application is resilient. So in AWS, you may need to deploy your application in different regions, so that in case one region is down, the application should be available in the other region.
Spot on. Thank you so much. Yep. So I'll be promoting Jacob to be the teacher, and I'll be the assistant teacher in. Yeah, but that is basically
Junior,
what?
Junior, can you throw a spanner into the works? Throw a spanner into the works by making it even more interesting. Can they differentiate for us high availability and fault tolerance and scalability?
I love that.
Yes.
So you already did the scalability part. Okay, someone come in with the fault tolerance. How do you differentiate fault tolerance from high availability? Anyone?
Okay, I think with the, I'll give it a shot. With the fault tolerance, we're looking at the ability of a system to continue operating even if one or more, even if one or more of its components fail. So when you have a component of a system fail, the system doesn't entirely shut down.
Okay. And okay, so that is fault tolerance. And how is it different from the high availability, like from your perspective?
How different is it from the higher availability?
High availability, yes.
I think with high availability, as Jacob put it, like a system remains up and running, like in all the regions, even if it gets a failure in one of the regions. It doesn't completely go out at all.
Okay. Yeah. Anyone with any other perspective before I bring in mine? The likes of Harriet are so silent. I saw Felix typing and then he stopped. Wake
Yes,
up.
I was just late. I was just late on my answer. So let me take high availability, then I'll take fault tolerance. So for my definition will be high availability is like a specific design that aims to minimize the downtime of a system or a service. So my fault tolerance definition will be I'm doing the differences with definition, by the way. So my fault tolerance would be the indication that the capability of a system or operation can tolerate an occurrence of a fault. So if, as Jacob or Isaac was saying, a system, let me even use my situation in Ghana, our power system. So in my home, I'll be having this meeting. I'll not rely on our national grid. I'll rely on maybe my power bank or my power station at home. So in case they take off the light, I have a backup at my end. So that's where I'll pick it from.
Okay. Perfect. And I love the explanation. And you just talked about power. And I realized how it's been raining heavily over here. So yesterday night, our Kenya power system, we normally call it anua. I don't know how to say it in English, where if your clothes are outside and it starts raining, you take them off. So we always joke about how our Kenya Power takes the power off when it starts raining. Yeah. So also over here, I'm fault tolerant using my backup power UPS in case a disaster occurs. I'm able to recover from that. Okay, so I think all the definitions were spot on over here. High availability. We are thinking in terms of uptime. I'm just saying in at any time when you talk about high availability, sometimes we are talking about numbers. For example, just going back to Amazon S3 and then we say it has 99.9% of availability. That means that at any point in time you want to access it, you'll get it. And what makes that possible? There is where the availability zones, deploying your applications in multiple availability zones, comes in handy. And when we're thinking about fault tolerance, on the other hand, we are thinking about the ability to recover. So kind of related to disaster recovery. So if our application is fault tolerant, as Felix put it, whenever a failure occurs, you are able to recover from that failure. And then scalability, which is also related to elasticity in a manner, is the ability of our systems to adapt to handle our different loads. So just getting into the discussion of today, which will be focused on high availability and scalability with regards to compute. So scalability, our system or our application can handle greater loads by adapting. And when we talk about scalability, we have two kinds. So we are thinking about either we are vertically scaling or horizontally scaling. And with regards to the exam, majority of the time when you talk about elasticity, we are thinking about the ability to horizontally scale, whereby we are adding more resources in terms of numbers to match the demand instead of just scalability, vertical scalability, where we are increasing the resources in that one particular application. So if we think about a call center, and this is an analogy I get from some Stefan Marek course. If you think about a call center, maybe we have a small junior operator. The junior operator handles, let's say, 20 calls a day. And then all of a sudden, there are many calls coming in. How do we vertically scale? So we are going to bring a senior operator who, for example, handles 40 calls a day. And there is when you're thinking about vertical scalability. So in short, we increased the resources to that one particular person. So if we're thinking about in terms of our compute, so we know about the instances. If you're thinking about the instance, majority of the time for us who are doing just some test workloads, we normally launch the T2 Micro, which is free tier. Gives us like one virtual CPU and I don't know if it's 1 gig or 2 gigs of RAM, but you'd have to confirm that. So if we are vertically scaling, that means that we are increasing the size of our instance. So if it was handling one virtual CPU, and then we maybe change to T2 large, it might handle more vCPU, more memory, and so on. And when do we use vertical scalability? When our systems are not distributed. Think about a database. When you think about two-tier or a three-tier application at any point in time. So we have the web tier, the app tier, and the database tier. We have our database in here, and then we have our web server, not web, but application server, sorry, and then the web server that is handling traffic. So it sends to the application server for processing, which may want to access our database. You know, we can horizontally scale, add more application servers to handle the traffic. But if we're thinking about a database like RDS, the relational database service, we have that one database which has all our data and so on. So for this database, if we want to scale it, we just can't go ahead and add more databases over here. What we'll do is we will increase the size of the database to host lots more data, but our application servers, even if we add more, we can still make them have access to the same database. And that is what we say, what I mean when I say, for example, this is a non-distributed system in this case. And I don't know where to find my eraser over here. Let me see. Yeah, I'll figure it out later. Okay, there you are. Cool. So that is a non-distributed system, a database, and the exam will test you on that. If you have a relational database, how do you scale it? We do not scale it horizontally, even though there is a way we scale it horizontally by adding read replicas, if you remember from the cloud practitioner. But the read replicas are not handling write workloads. So the primary database, we scale it vertically. And there is always a limit to how much you can scale in this case. That is the hardware limit. If our instance is maybe too large, it has a specific RAM, virtual CPU, then we hit that limit and boom, we can no longer scale. And how about horizontal scalability? If I think about our call center, we had one small person who handled 20 calls a day, and now more calls are coming in. So instead of feeding that person so that they become full and they'll be able to handle operators who will each handle 20 calls a day, and that is horizontal scalability. So in terms of our compute, we are increasing the number of instances or our systems for our application. Where do we use horizontal scaling? Now, the opposite. When we have distributed systems, and there you're thinking about web applications, mobile applications, when you are setting up microservices and so on. And it's very easy to scale, horizontally scale in the cloud. For example, if we think about Amazon EC2, we can add more instances as and when we need them. And then we have the concept of high availability. High availability, we normally say, goes hand in hand with horizontal scaling. Because what does it mean? Now we have our operators. Some of them are in maybe the building in New York. We have different branches. We have a second building in San Francisco. What high availability means is that division, whereby in case something happens, maybe there were floods in New York or something, and that call center is not reachable at all, the customers will still be able to have their issues handled from the San Francisco region. And that is the purpose of high availability. We are running our system in at least 2 data centers, which when we think in terms of AWS, availability zones, which consist of multiple data center. And why do we ensure high availability? In case data center goes down, our applications will still be available. And then when we think about high availability, it can either be passive or active. What do we mean by passive? If I think about RDS multi-AZ, how does RDS multi-AZ work? We have our primary database and our secondary database, or you can call it a failover database. When we say it's passive, this is in AZA and this is in AZB. So in case anything happens to availability zone 1A, but maybe before I go to that, this primary database is handling both write traffic and read traffic. Our secondary database is just chilling. So in case a failure happens, what happens is maybe as the A goes down, the secondary database is automatically promoted, call it promoted to the primary database. And even before the failover happens, there was some sorts of replication happening between the two. So that is what we call passive, whereby if it's passive, one of the one of our database was sleeping while the other was awake and handling all the requests, or our high availability can be active in this case. For example, if you're thinking about horizontally scaling, we have our web tier bringing in connections from different users. If we have server 1, server 2, server 3, server 4 handling traffic, and they all hit 100% CPU utilization, we just add another server and redirect traffic to it. That is active high availability. So just moving on, we have talked about vertical scaling. An example over here, we are moving an instance type, and vertical scaling, because it's vertical, we call it scaling up and down, right? So for example, from a T2 Nano to this metal instance, which has like 12.3 terabytes of RAM and these many virtual CPUs, that is vertical scaling. Horizontal scaling, scaling in and out, increase in terms of number. This one is in terms of resources. And in terms of numbers, what helps us with that? That is where the auto scaling group and the load balancer come in place, which basically is what our discussion is about. And then high availability, as we talked about, that replication on different data centers. So we run our instances with the same application across multiple availability zone, and we are still taking the two services, but making sure they are available in multiple availability zones. So we get started with the load balancer. Now, a load balancer balancing the load. So if we have a load balancer over here, there are servers that forward traffic to multiple different servers. So we have our applications running on the EC2 instances, and when our users try to access our instance, instead of accessing the servers directly, we integrate a load balancer over there. What the load balancer will do is just distribute traffic evenly across the downstream servers. And that is what a load balancer does. But in AWS, we have what we call an elastic load balancer. This is managed, and anytime we talked about a managed service, RDS is managed, we have Beanstalk managed. So AWS takes care of it, make sure it's working, takes care of upgrades, backups, maintenance, and so on. And the load balancer is integrated with lots of other services. EC2 will be talking about auto scaling groups, but we can also integrate it with our containers, Elastic Container Service. We can attach the certificate manager to it. I'll talk about that. We can integrate CloudWatch for monitoring the requests coming into our load balancer. We can integrate with the DNS. I think in the morning I saw something about Route 53 being talked about. We can integrate with our firewalls and global accelerator, and so on and so on. And how does a load balancer work? Before we get into which load balancers we have, it performs health check. Before you send traffic anywhere, you want to ensure that that specific server is healthy. So health checks enable the load balancer to know if I am forwarding traffic to this specific instance, will it be able to handle that traffic? So it only forwards traffic to the servers that are healthy. And how does it ensure the server is healthy? It will do a health check, which is done on a specific port number and a route. So for example, here, for this specific instance, we are saying, just do a health check on this protocol, HTTP, the port number is that, and the endpoint could be that, or the endpoint could be root. You'll see that in the demo we do. So if it does not give up a 200 status, okay, then that instance is unhealthy and we won't send any traffic to it. So in AWS, we have talked about the Elastic Load Balancer. We have 4 kinds of load balancer. And back to you. What are the types of load balancers we have in AWS? Bring them coming. So you mention what it does or what traffic it handles from the CCP. Come on. Silence. What are the different types of load balancers? Okay, someone is typing. Aha, we have the application load balancer. Felix, maybe Felix, what traffic does the application load balancer handle? And Jacob, you are unmuted.
Yes, so I wanted to talk about the network load balancer as well.
Mm-hmm.
Yeah.
What
So that one handles. So it
mm-hmm.
handles TCP traffic.
Yeah.
Okay. Also, I think also it handles TLS as.
Okay, TLS, TCP, traffic. Felix, I'm still waiting on the chat on what traffic the application load balancer handle. So application load balancer, network load balancer. What is the other load balancer type? We have the classic load balancer. You can tell us a little more about it.
So this is the older load balancer that would handle all because currently now we've separated into network and application. So the classical load balancer handle with the old service that handles both application and network load balancing.
Awesome. Okay. One more type of load balancer to go. This one, yeah, was not covered in depth in the cloud practitioner. But what is the other type of load balancer? TikTok, TikTok. The gateway load balancer. What does the gateway load, what type of traffic or what exactly is the gateway load balancer about? And Felix, I see your hand up. You can come in.
Application load balancer, I think it balances load which come from like HTTPS. I think it's also work with Route 53 to balance load.
Okay. Nice. Awesome, awesome. Okay, thank you so much. So I can see Felix on the chat, other Felix, also typing. Let me wait on the gateway load balancer. So while we wait on that, so I'll just go ahead and cover. Now in the cloud practitioner, you are not needed to go deeper and understand all these load balancers, but in the solutions architect exam, the exam expects you to know more than just the name of the load balancers available. So we have 4 kinds of load balancers, but I will just say 3 because this one is deprecated right now. It's no longer in use, the classic load balancer. So you see it's the old generation load balancer. And this one handle the traffic that both the application and the network load balancer handle. So HTTP, HTTPS, TCP, SSL traffic. And then we have the 3 newer generation load balancers, which is the ALB, application load balancer, as Felix Courier mentioned, the network load balancer from Jacob, and the gateway load balancer from Felix. So the application load balancer, Felix mentioned it handled the HTTPS traffic, but also the HTTP and another type of traffic called the WebSocket, which is used for things like chat applications where you need a connection setup. So for example, if I'm building a chatbot, I need to set up a connection, an end-to-end where we are communicating. So think of it like a phone call or anything. And then we have the network load balancer, which handles TCP, UDP traffic, TLS traffic, secure TCP. And what you notice over here, if you remember the OSI model, it has 7 layers. So at the 7th layer, we have the HTTP, the application layer, which handles HTTP. So that's why we say the application load balancer works at layer 7 or handles layer 7 traffic. The network load balancer, on the other hand, if you think about TCP UDP traffic, these are traffic at the layer 4. What is layer 4 of the OSI model? OSI model. The network engineers in the house. What is layer 4? No network engineers. But yeah, not specific to network engineers. Just, yeah. I think if you did any IT, you should have done like the OSI model even in campus or whatever you studied. What is layer 4? Or Google. There is also ChatGPT, it can tell you. Transport layer, exactly. So at the transport layer, we have the TCP and the UDP protocol that work over there. And then we have the gateway load balancer, which operates at layer 3 of the OSI model, the network layer, which handles the IP protocol. So just diving deeper into this, because as I mentioned, at the exam, you're expected to know more than just the name of the load balancer. So for example, how does it work? The user sends, for example, a HTTP, HTTPS request, and so on to the load balancer. The load balancer directs that traffic to the downstream server. The server gives a response, and the load balancer gives a response back to the client. So I'll start with the classic load balancer, and I am not talking much about it because I just mentioned because maybe it occurs. I'm not sure if it will still occur in the exam because it's deprecated. But this is the old generation load balancer. Supports both layer 4 and layer 7. So we are talking about the transport layer and the application layer. So it has a fixed host name, for example, if you want to reach this load balancer, the name of the load balancer, the region, ELB, Amazon.com. So nothing much to talk about it. So the only thing you need to know, it supports both layer 4 and layer 7, older generation for now. Now the exam will ask you a lot about the application load balancer, most common load balancer or commonly used load balancer, because we have a lot of web traffic, right? HTTP traffic. A lot of people on EC2 instances are hosting websites and so on. And we are using the HTTPS protocol. So one thing, the first thing operates at layer 7, and we are load balancing to multiple applications across different machines. And what do we call those machines? A target group. A target group contains, it's a group which contains all these different servers that will handle that traffic. Or even if it's not across machines, if you remember before I said with the load balancer, we can distribute traffic across containers. So if you see ECS, Elastic Container Service, so we can, the application load balancer also supports balancing to multiple applications on the same machine. Here we're talking about the virtual server and how through the containers installed in it. So it supports also the WebSocket protocol, as I mentioned, and it also supports redirects. For example, if someone is trying to access your website using HTTP, you want everyone to access your website securely, so it will automatically redirect to HTTPS. So we have the different target groups. We'll also see in the demo. I just want to finish the theoretical part and then we go to the console. What are the different target groups? And remember, the target group is just a combination of servers that will handle that traffic. So this could be EC2 instances, and also they could be managed in an auto-scaling group, which we'll discuss. They could be the Elastic Container Service tasks. So if we think in terms of containerization, it also forwards traffic to Lambda functions. And this is a question that the exam might test you on. What are the different target groups, or which one is not a target group? And apart from that, it can forward traffic to IP addresses, and these addresses must be private. So you can specify which private IP addresses will receive traffic from your application load balancer. And now, something at the solutions architect level you need to know about the application load balancer is how it routes traffic. There are different ways the load balancer can route traffic. So it can route to multiple target groups based on different parameters. So it can route based on path in the URL. For example, I have my application called example.com, and example.com, maybe it's a shopping website or a post website or Facebook. So if someone needs information about users, for example, we have the users path, we have the post path, we have different paths, maybe search, if you're searching for a product, and so on and so on. So the application load balancer can route traffic based on that. And it's the same, so you don't have to create multiple of these load balancers. So for example, over here, we are saying if the user is trying to reach our website and they are trying to access using the user path, direct that traffic to this target group called users. And this target group will have EC2 servers that will be handling that specific path. And if other user is coming and accessing example.com, but through the search path, maybe they are trying to search for specific product, I'm going to redirect that traffic to target group 2, which is also a group which contains servers. So that is something you need to know. The load balancer can route based on path. It can also route based on the host name in the URL. For example, same application, but different domains. So for example, this is 1.example.com, or the other is other or 2.example.com. So it can, the load balancer, we can specify routes that if a user is accessing example.com but under this host name, direct that traffic here, then this other traffic here. So we can set up all those routes, and that is available with the load balancer. We can also do routing based on the query strings or the headers that come within the request. And an example is over here. So if a request is coming in and the query strings over here are set up, this user is trying to access our application using a mobile phone. So if their platform is mobile, we know that we need a certain layout. So the target group 1 is redirect that traffic to these EC2 instances, which will handle the mobile application. And if the query string or the headers which are included in the request, this person is trying to access our application through a desktop app, we can also specify a different target group. And remember, the target group does not have to be EC2 instances. As we mentioned, it could be Lambda, it could be ECS, the container service, but it also could be private IP addresses. And that is where you see the on-prem world coming in. So if I have an on-prem server that is handling a website, I can actually just specify the private IP of that server in the application load balancer. And that way the load balancer can also distribute traffic to on-prem servers using their private IP addresses. So that is it about the application load balancer at a high level. So we use the load balancers for microservices. We can also use them for containerized applications if you are running Docker apps or you are using the Amazon Elastic Container Service, and so on and so on. So some other aspects you need to know about the application load balancer. We are not done. So it has a fixed host name. I'll show you that in the demo. The host name you'll use to reach the load balancer. And as Felix mentioned, you can integrate with Route 53 and give it your own host name. For example, say the ugusergroup.com should direct traffic to the host name of the load balancer. And one thing to notice, the servers don't see the IP of the client. Also an exam question. As I mentioned, I'll be giving like things that you might be asked in the exam if you're preparing for the solutions architect. There is an issue. So if the client is trying to access our application, they hit the load balancer with this specific IP. The load balancer will do the connection termination over there and send that traffic to the EC2 instance. So that EC2 instance will not know the IP of the client. It will only know the IP of the load balancer. So if we want our servers And yeah, I marked it on red because it's something you need to remember. If we want our servers to be able to know the IPs of the client, it's inserted in this specific header. So you have to remember this: X forwarded for, X forwarded port, X forwarded proto. How to actualize it? Now you don't need to know about that. You just have to remember those specific headers. If the exam questions asks you, so it will ask you, is it not possible at all? Or how will our servers know the IP address of the client if we want to? So there is these headers, which will always contain information about the IP of the client, the X forwarded for the IP, port for the port number, and proto for the protocol that the client is using to access our application. So this one is exam key concept, those specific headers. And that is it about the application load balancer. Unless there are any questions, you can put them in the chat and so on. Okay, so network load balancer. As you all mentioned, TCP UDP traffic. Now, one thing that comes into the exam, they will always ask this question. The network load balancer is for very high performance, okay? Handling TCP and UDP traffic at layer 4 of the OSI model. So if the exam asks you, you want to handle millions of requests per second, the application load balancer does not give us this speed. Only the network load balancer will do. So it has very less latency, 100 milliseconds. And you can see for the application load balancer, it's 400 milliseconds. So this is one keyword that will direct you to the network load balancer in the exam. Of course, the kind of traffic is TCP UDP. Now, the network load balancer has one static IP. In the application load balancer, we are seeing we are being given a host name. But in the network load balancer, will be assigned a static IP. So if you have any applications that need a solution where they can access maybe a specific IP address, you can use the network load balancer for that, and so on. And as I mentioned, very extreme performance in the exam, very less latency, you'll go for that. And this one is not included in the free tier. So same way the application load balancer works, it can redirect traffic based on specific paths, for example, the users, the search function, and so on. And then the targets of the network load balancer. It can direct traffic to EC2 instances. IP addresses must be private. And you can see here now you can specify your on-prem server. Or it can direct traffic to the application load balancer. You have to remember that. What is missing over here? Lambda and ECS containers. So the network load balancer does not forward traffic to Lambda, and it does not forward traffic to container services. Only EC2 IP addresses, or it can also direct traffic to the application load balancer. So you have to note that down. So if the exam is tricking you, we have very high performance and so on, but we want to direct traffic to Lambda functions, then yeah, you just have to go for the application load balancer. And then we have the other type of load balancer, which was not discussed in depth in the cloud practitioner level, the gateway load balancer. What do we use the gateway load balancer for? Manage third-party virtual appliances. So for example, you have firewalls. Maybe you have, if we just think about security in terms of the cloud, if we think about the enterprise security services that we have, of course, they offer us better capabilities than just the security groups or the network access control list if we're thinking about firewalls in AWS. So if you want your traffic to be inspected, maybe, I don't know if you're familiar, so could be Fortinet, could be some Cisco applications, whatever you can think of. If it's a firewall, could be Palo Alto, whatever stuff you have been running on-prem, and you can use that in the cloud. So we want some traffic inspection. What do? We use a gateway load balancer. So if our user is trying to access our application, instead of the traffic going directly to the application, the traffic goes through the gateway load balancer. The gateway load balancer will distribute that traffic for inspection. Maybe here we have an inspection or an intrusion detection system. So we check that traffic. If the traffic is bad, it's blocked over here. If it's okay, the traffic is now redirected to the load balancer and to the application server. So you have firewalls, IPS, IDS, deep packet inspection, and so on and so on. We want to do some manipulation to the body that the client has sent. So we can use the gateway load balancer. It operates at the network layer of the OSI model, so layer 3, and so on. So I think that is all you need to know about the gateway load balancer. So if the exam is telling you you are managing some third-party appliances, you want your traffic to be inspected before it's sent to the application servers, then the gateway load balancer comes in handy. And so it works as a gateway, and it also works as a load balancer, because if lots of traffic is coming in, these third-party tools, we can also scale that, and the load balancer will distribute traffic across them. And it uses the Geneve protocol. So that's it. And the targets of the gateway load balancer, EC2 and IP addresses only. So you can use EC2 instances or also your on-prem servers by specifying their private IP addresses. So the exam is most likely to test you about the application load balancer, the network load balancer, and just a little bit about the gateway load balancer. And Terence, you can come in.
I want to complicate things a little bit, but it's something that they must know from an engineering perspective. Now, 3 or so questions, but it's something that you must know quite well.
Yeah.
We had TCP, we had UDP, and now I'm hearing Geneve. Can you tell us on what ports those particular protocols are operating on? Felix, TCP is operating on which, that's Felix Fianyeku. TCP is operating on which port? Pass the question to the next guy if you are not getting it. Hey, Jacob, UDP is operating on port number? Those are things you must have on your fingertips if you're in this business.
Yeah.
At least Geneve is there. It has been exposed to you. So I'm not going to ask. It's just there.
You know it.
And the database SQL is operating on which port? When you SSH, you are SSHing through which port? When you RDP, you are RDPing into a Windows server through which port? Pauline, carry on. You can see they'll be caught off guard.
Yeah,
they're ghosting me.
So Taris is taking us on speed. But
no, those are things you must have on your fingertips. There is no there's no speed over here. These are things if your mother wakes you up at 2 a.m. and asks you TCPs on which port, you should tell her. Otherwise, you are not ready for architecture. Over to you, Pauline. Carry on.
Let me see, they are typing something. Maybe they'll give us an answer. I see Felix mentioning HTTP port 80.
Okay, HTTPS, Felix.
SSH 22.
Telnet. There's some of these common applications that are used. You must know those ports. Otherwise, you're outside the game and you're not ready to advise the client as a what is it? As an architect.
Yeah.
So over to you, Junior. Carry on.
Okay. Yeah, I see them coming in. He also asked about my the MySQL and so on. You can put them there. Thank you so much. Okay. So I'm moving on to something also that was not discussed on at the cloud practitioner level, but very important to know when we talk about the solutions architect level. And the first thing I'm going to talk about is sticky sessions. So by default, our load balancer will just automatically distribute traffic and balance them across all the servers. But what if you want, maybe you have a requirement that the same client is always redirected to the same instance in the same load balancer? That is when you enable sticky sessions, or in other terms, session affinity of the load balancer. So it works with the CLB, the ALB, and the network load balancer, and it uses the cookies we use for that stickiness. And you can enable like an expiration date. Now, all the other things you don't need to know except the first sentence that I put over here, because the exam will test you on that. So how it works, you have client one. By default, what would happen? Client one comes in, traffic goes here. Client 2 comes in, traffic goes here. Client 3 comes in, traffic goes here. Client 1 comes in again, they'll be directed to the other instance to this way, because the load balancer knows my work is load balancing, and I will keep distributing that traffic. So if you have a requirement where the same client should always be directed to the same server, if you enable sticky session, if client 1 makes a connection, they'll be directed to the first instance. Client 2 may be the second instance, and client 3 may be the second instance. If client 1 maybe tries to make a connection again, they will always be directed to the same EC2 instance that handled their request, because we want to maintain that session. So exam asks you on that, you know, the solution to that for our load balancer is to enable sticky sessions if we want our clients to always be directed to the same instance. And they'll put it as a scenario. Or the client is complaining that every time they access our website, they get logged out or something after some minutes. So those are some of the use cases where enabling sticky sessions is important. The exam will test you on this. You don't need to understand cookies and so on and so on. But you see, they are used for enabling the stickiness of our load balancer, and you can control the expiration date. So the things I marked in red over here, so you can create, so we have different types of cookies, either application-based cookies or duration-based, maintaining the duration of that client. So for the application-based cookie, it can either be custom, you specify the custom, or a cookie generated by the load balancer. So if you enable custom, you're setting up everything custom on your own. You have to give them names, right? And you cannot give them these specific names. And that is the only thing the exam might test you on. Which ones can you not name your load balance, your cookies, if you're creating custom cookies? So we have the AWS LB, AWS LB app, AWS LB target group. All these cookies are used by our load balancer if we're thinking about an application-based cookie, which is generated by the load balancer, or the duration-based cookie generated by our load balancer. So you can see all these names, AWS LB, AWS LB app. These are the names which are used by our load balancers if the load balancers generate the cookies themselves. So you cannot use them for your custom cookie. So AWS LB, ALB app, ALB target group, TG. Only those three. Hopefully you can remember, you took a screenshot or something. Okay, so I have talked about more features about the load balancer, sticky sessions, uh, how they work, and they use cookies. The other thing that you might need to know at the solutions architect level is the issue on load balancing. So we have this concept called cross-zone load balancing, which is a feature you can enable in your load balancer. If your load balancer spans multiple availability zones, because we are saying we want to maintain high availability, what happens if you don't enable cross-zone load balancing? Traffic will be directed like this. So our user are trying to reach out our application load balancer. So if we don't enable cross-zone load balancing, so 50% of the traffic, maybe there are 50 requests coming in. So 50 requests will go to availability zone 1, 50 requests will go to availability zone 2. And if we have only 2 instances in availability zone 1 and 8 instances in availability zone 2, what will happen? Availability zone 1 will become overwhelmed in a manner because only like it's like we're doing half the traffic between the two availability zones. So 25 requests will go to instance 1, the other 25 requests go to instance 2. But what happens in the other availability zone? You just do your 50 divided by 8, and each of these instances received like that small amount of traffic. So you might get that some instances are actually being overutilized in one availability zone. And to prevent this from happening, when we are using a multi-AZ load balancer, we enable cross-zone load balancing, where that traffic will be evenly distributed across the registered instances in all the availability zones. So if maybe we are receiving 100 requests from our application, so it will just count what are all the instances running in all our availability zones, and each of the instance will receive like 10% of the traffic. So that is cross-zone load balancing, a feature of the load balancer you might also be asked about in the exam. So you want your request to be distributed evenly across all the availability zones. You enable cross-zone load balancing. And one thing to notice, for the application load balancer, this is by default. So by default, it's already enabled and you can disable it. But for the network and the classic load balancer, which I don't think you'll be asked about, the network load balancer and the gateway load balancer, cross-zone load balancing is disabled. And if you enable it, you're going to pay for that. So for the load application, it's enabled, but you don't pay for it. For the network and the gateway, it's disabled. If you enable it, you are charged. For the classic load balancer, it's also disabled. You don't pay if enabled, even though it's unlikely that at this point in time, the classic load balancer will be mentioned in the exam, but good to know just in case it is mentioned. So that is another feature, cross-zone load balancing. And then we're talking about the integration of the load balancers with the certificate manager. So if we have certificates, because we said we enable HTTPS traffic. So this is secure HTTP. And how do we enable that security? By using certificates. So how does that work? So just an information about the certificate. The SSL certificate allows encryption in flight or in transit. So the traffic between your clients and the load balancer is encrypted. So we have SSL, secure sockets layer, used to encrypt, and TLS is the newer version. And if you have ever purchased a certificate and so on, we know the likes of GoDaddy, DigiCert, they issue public certificate. So back to our load balancer, it allows us to use our certificate for it to enable that HTTP or not HTTP, HTTPS or secure traffic. So we can manage our certificates using the AWS Certificate Manager. And you can also upload your own certificates to Certificate Manager and specify that certificate should be used by your load balancer. So when you create a listener, we'll see that in the demo. Hopefully I have time. You can specify what will be your default certificate. And then the other thing that now comes to or will be asked about in the exam is the server name indication. So I talked about the certificates just to bring you to the topic of server name indication, which is something that also can be asked about in the exam. So if you want like HTTPS traffic to be enabled, of course you have to specify which certificate is it going to use from the AWS Certificate Manager. Now, what is server name indication? So if we have multiple websites, for example, we're talking about our load balancer over here, saying that if someone is trying to access www.mycop.com I'm going to send that traffic here. If someone is trying to access example.com, I'm going to send that traffic to the second target group. So what do you do now? Will you come and put like, so you are going to load multiple certificates. So I'm saying that if someone is accessing HTTPS, maybe www.mycorp.com, I'm going to load multiple certificates over here. So what is server name indication? It solves the problem of loading multiple certificates. And so instead of, so when the client makes a request, for example, I want to access mycorp.com, the ALB will now know, okay, if the client wants to access this specific, I know where to find that certificate. So it will go and use the correct SSL certificate. And that is what server name indication is about. The server will find the correct certificate or return the default one. And with server name indication, it only works with the newer generation. And classic load balancer, you won't be asked about that. So the exam, of course, in the solutions architect, it's more about solutions. Which solutions are you offering? So if you want to solve the problem of, you don't want to load all. So if we have like 10 target groups, are we going to load 10 certificates on our servers or what? So that is when we do the server name indication. The client will make a request and they'll indicate which specific domain or which specific servers they want to access, and the load balancer will automatically get the correct certificate that will be used. So the classic load balancer, for example, supports only one certificate. So you have to like create multiple SSL certificates if you have like multiple host names. And that is why we say the server name indication is only used for the newer generation. So you can create multiple listeners. So I'm listening on port HTTPS on protocol 443, and I'm sending my traffic here. And you can have multiple certificates, and how it works in the background, it will use the server name indication to say that if you want to go to this specific target, I'm going to use this certificate. But with the classic load balancer, you have to create multiple classic load balancers because you have to upload only one certificate to that load balancer. So server name indication enables us to use multiple certificates for multiple targets in our load balancers. And I think that is it about some of the features you'll be asked about the load balancer in the exam. Okay, one last feature and it'll be done. So we have talked about sticky sessions. We have talked about cross-zone load balancing. We have talked about server name indication to solve the problem of multiple certificates. And then this one is very easy. Connection draining is also a feature you might be asked about the exam. For the newer generation load balancers, it's called deregistration delay. So what does this mean? With connection draining, we want to complete all requests before. For example, what happens? Our load balancer over here, users are trying to reach it. Maybe this instance is marked unhealthy, or maybe we are scaling down or we are scaling up. So our traffic is now low and we need to terminate one of these instances. Are we just going to terminate it immediately? No. This is where connection draining or registrational delay happens. So if there were any requests that were being handled over here, we want to wait for those requests to finish before terminating that specific instance. So connection draining or registration delay is a feature that enables us to complete all the in-flight requests if the instance is deregistering from the target group or it's unhealthy. So we want to stop sending requests. So this is deregistering. We are not going to send more requests over here. Let it complete all the requests it was handling. All the requests coming in will be sent to the other servers. And once it completes the request, we are going to terminate that instance. So now the issue with this is you have to set up the value depending on how you know your application handles request. So it could be between 1 and 3,600 seconds. By default, it's only 5 minutes, okay? So if you know your application will take longer, then you have to edit this value, add more minutes to give your instances time to deregister. Or you can also disable it, whereby in case a scale down event is happening and so on, we are going to automatically terminate that instance without waiting for the connection to drain. So I think that is the last feature of the load balancer that you might need to know of in the solutions architect level exam. So almost wrapping it up. Yeah. The last thing, autoscaling. Autoscaling is not complicated at all. So we have talked about the load balancer. And now how do we work with the load balancer? The load balancer works hand in hand with the autoscaling group to ensure the high availability and scaling aspect of it. So what is the goal of the autoscaling group? We want to autoscale. You see the word auto, scale out automatically, add more instances to match increased load. If the load decreases, we want to remove instances. We want to ensure we have a maximum and a minimum number of instances running at any point in time. If we have a load balancer, and for example, we add more instances, we want them to be automatically registered to the load balancer in that. For example, here we have 1, 2, 3, 4 instances running. If we are auto scaling and then we add instance 1, we want it to be automatically registered by the load balancer and start receiving traffic. And that is it. And then we want to recreate an EC2 instance. For example, if this instance is marked unhealthy, it gets terminated and a new one is recreated. And that is the whole purpose of the auto scaling group. It also works hand in hand with the load balancer. So we use the load balancer, we create a target group, which consists of our auto scaling group, and our load balancer will evenly distribute traffic in there. So you don't pay for the auto scaling group, you only pay for the instances that will be launched by the auto scaling group. For us to create our auto scaling group, we need a launch template. What is a launch template? It's more of a recipe, which is giving us, okay, I want to create an EC2 instance. These are the things I need. I will need an Amazon machine image for this auto scaling group. And you can see all the features are related to when you are launching an EC2 instance. Because the auto scaling group is launching EC2 instance, it wants to know how exactly I'm going to launch it. Which Amazon machine image is it going to use? What is the instance type of this instance? Which EBS volumes are going to be attached? Because I'm going to launch them automatically. What are the security groups? What is the key pair? Are there any roles? And so on, and even the user data. So you just think about the process of launching an instance, and that is what you need when launching when using a launch template that will be used by our auto scaling group. Some other things, you have to specify the minimum size, the maximum size, the initial capacity. So if our auto scaling group is being created, what is the minimum size of number of instances that will be running? What is the maximum number of instances that will be running? How many do I want to launch now? And then the scaling policies, which I'm going to talk about. So with the scaling policies, how do we scale? We can scale based on CloudWatch alarms. So we are setting up an alarm. For example, if the average CPU is more than 40%, add an additional instance. So and so on. So based on that alarm, we can either add instances or remove them. So for example, we say our CPU utilization should always be around 70%. If it goes above that, and we have set up our policy, our auto scaling group will automatically add additional instances based on the policy we have specified. And what are the different policies that we have available? We have, in terms of dynamic scaling, we have the target tracking, simple and scheduled. Very simple. The target tracking policy, I'm just saying, I want the CPU to stay around this percent. It's the way you set up the temperature of your home. You're saying that my temperature should always be around this percent or air conditioner and so on. So if it's so cold, it will try maybe heat up the room. If it's so hot, we will cool down the room to maintain a certain temperature. So that is target tracking. If I say I want my CPU to stay around 40%, if my CPU utilization now is going to 70%, it will add more instances to handle the load. If it goes way below, maybe my CPU utilization is now 20%, it's going to remove instances. Simple and step scaling, you configure everything yourself. So you have like 2 alarms, when to scale up and when to scale down. So you are saying that when the CPU is above 70%, add 2 instances. And when the CPU is below 30%, remove 1 instance. So you have specified everything. What happens above this threshold? What happens below this threshold? And scheduled just from the term scheduling. I know Friday is Black Friday and lots of participants will be accessing my website. So I'm just saying that my capacity right now, my minimum capacity is 5. But because Friday is Black Friday and I know there are lots of users, when it gets to Friday, my minimum capacity should now be 20. So it will automatically scale to meet that value on Friday. And then we have the predictive scaling, which uses machine learning to focus. So how it works, it will analyze historical data. How has this application worked over the past 3 months? And then generate a forecast. Okay, so if the past 3 months, Monday, Tuesday, Wednesday, not much workload, and then Thursday, Friday, Saturday, the workload goes up, it will generate a forecast from that and now schedule a scaling action in the future for you because it already knows how your scaling works. So the policies: target tracking, simple scaling, scheduled scaling, or predictive scaling. Depending on how the exam is structured, if you have just this understanding, you should be able to answer any question asking you on which scaling policy should you consider for a specific use case. And now wrapping up the scaling aspect of it. So there is something called the scaling cooldown. So kind of related to the connection draining, but different. Anytime a scaling activity happens, you get into the cooldown period, which is a default of 5 minutes. And what is cooldown? So, for example, I have my target tracking policy has said when my CPU utilization, okay, or my step scaling have said when my CPU utilization is above 70%, add 2 more units. And now my CPU utilization is 80%. These 2 instances are launching and I am in the alarm state right now. So the cooldown period, if I say 5 minutes, I am just saying, please wait for 5 minutes and confirm that these 2 units are added before trying to launch additional. Because if we do not specify this cooldown period, the auto-scaling group will be like in panic mode. Gosh, the CPU utilization is still 80. So it will keep adding, launching. So the cooldown period helps with that. Wait 5 minutes, and this is because I'm saying I know my instances. So wait for some 2 minutes for those instances to launch. They will start receiving traffic, and maybe the CPU utilization will now go back to 60%. So, and that is also the same way when terminating. Now my CPU utilization, I said, when it's below 30%, terminate 1. And my CPU utilization is 20%. If I don't give it a cooldown for it to make sure the instance has gotten into the terminating state, the auto-scaling group will also get in panic mode. I have to terminate. So that period is just chill, wait for 5 minutes first, confirm that it has been terminated before doing the next scaling action, and so on. So that is the purpose of the cooldown period. So if a scaling action occurs, either scaling up and down, it will ask, are we still around the cooldown period? If yes, ignore any action to scale. If no, you can go ahead and launch another instance or terminate another instance. Any questions so far? Okay. If there are no questions, I planned to work on a couple of demos, but I won't be launching lots of stuff. I'll just show you the different options that we have available and then cover the last service, which is Outpost. So some of the things I mentioned, when you go under the EC2 section, hopefully by now, everyone in this room knows how to launch an instance, how to terminate instances, and so on. So I'll talk about the auto-scaling group, and then the load balancers, and the target groups, and so on. Just an overview. So for example, if I want to create, let me start with the load balancer because that is what I talked about before. And should I zoom in a little bit? Not sure if my page is visible enough. So if I go ahead and create a load balancer, you can see the different types I have available. And I told you the classic is deprecated. So we have the application, network, and gateway. And you can see the application handles HTTP, HTTPS traffic, and the target group could be, if you know the icons, you will know this is a Lambda function, this is a container, or an EC2 instance. So those are the different target group, and you can see the classic load balancer. It's still available for businesses who are using it before. You can create it, but it's like hidden, previous generation. And then we have the network load balancer. You can see it handles TCP, UDP, TLS traffic, and the targets are either an application load balancer, some specific EC2 instances in there, private IP addresses to mention. And then the gateway load balancer, you can see now over here, it's like security services, like firewalls. So any third party appliances you have available. So if you go ahead and create, I won't create one, just showing the options available. The load balancer, you give it a name, UG user group, oopsies, UG user group. Is it an internet facing or internal? Internal serves internal traffic within our VPC. Internet facing will serve internet traffic. And then the IP address type, do you want to only include IPv4, or you can set up dual stack, which can redirect both IPv4 and IPv6 addresses. And then the network, what is the VPC? So I can select the default VPC and which availability zones will the load balancer be available in. And you can see select at least 2 availability zones where so for example, availability zone 1A and 1B. And if it's supposed to be public, so you can specify this should be a public subnet where the load balancer is available in. And then the security group. Remember, for the security group of the load balancer, it should allow HTTP traffic from the internet. So you can create one security group. I'm not sure if I have any for load balancer. I have a lot over here. But let me just imagine the default. But you have to set up the rules. You can create a new security group, say that this load balancer should accept HTTP traffic from the internet. And then when I talked about the listeners, so you can see that the protocols available, HTTP traffic forward to where, and this is where you select the target group. And if you see the options on creating a target group, for the load balancer, of course, a target group could have EC2 instances, could have Lambda function, could have ECS containers, and so on. So while that loads, so you are saying that if traffic is coming through port 80, forward that traffic over here. And then you can add even multiple listeners. So that is a tag, remove, add a listener, and so on. And I can say, so this is HTTPS traffic. If it comes in, forward to this specific target group, and you can also set up redirection. So if any HTTP traffic is coming in, I want you to redirect that to HTTPS. Now, speaking of the target group, nothing complicated to set up. So you can say, what does it have? Instances or IP addresses or Lambda function or an application load balancer. So I can say, this is for instances. I call it the UG target group. Which traffic is coming in? So for example, HTTP traffic, IPv4. This target group is in that specific VPC. You see the health check. The load balancer has to perform a health check. So the associated load balancer will send request on which path. So you can select maybe HTTP, maybe you have a specific path you can enter or a specific route and so on. So you go ahead, select the instances if they are available. If not, it's still okay. Review the targets and create your target group. So that simple. And now you come back and say, my specific application load balancer should forward traffic to this specific target group I have created. And then listener settings, you can set up default server certificate. So where are you getting your certificate from? You can get from the AWS certificate manager. If you have a certificate set up there, you can include that or import your own certificate to SSM to the auto scaling group and so on and so on. And if you want even more integration, you can integrate with the CloudFront, set up a CloudFront distribution and so on, or a web application firewall, global accelerator, also integrated there. So on and so on, you go ahead and create your load balancer. Oh, I did not specify that. No, I'm not importing default SSL certificate. Yeah, because I enabled HTTPS. So I'm going to remove that. And yeah, you go ahead and create your load balancer. So after creating your load balancer, what else do you need? You have created your target group. You can also set up an auto scaling group. So if you create an auto scaling group, the first thing you have to choose is a launch template. And what is a launch template? Maybe I'll just open this tab to see how you create a launch template, all settings that you use to create a launch an EC2 instance over here. So if I create a launch template, so I'll give it a name, UG launch template, no version description, or I'll just say LT for UG. And then this launch template is going to be used for auto scaling. So you can see the selection. Which Amazon machine image am I going to use? Am I going to use one owned by me? So if you have a specific template, you can specify over there. If you just want to use the normal AMIs from AWS, you can also select from here. That is the quick start. So Amazon Linux 2, AMI, and so on. So I can select that, Amazon Linux 2023. What is the instance type? And this launch template is going to be used by our auto scaling group. So maybe T2 Nano, smallest EC2 instance type we have available. Which KPI is it going to use? I can skip that. The network settings, where the subnets where we are going to launch our instances. So you can either select that or skip that. The security group that is going to be used with our instances, you can select an existing or create one. So for our instances security group, it will be like, I am accepting traffic, HTTP traffic, as long as that traffic is coming from not anywhere right now, but you're saying that traffic is coming from the load balancer, because users will hit the load balancer and then the load balancer will distribute traffic to the servers. So you have to make sure you set up your security group settings correctly. So I'll just select an existing that one test. I'm sure it does not work out. And then the volumes, advanced details. So you can see it's just the settings that you use to launch an EC2 instance. If you have user data, you can place over there, create your launch template, and now use that launch template to create your target group. So the UG launch template. Next, what is missing? UG auto scaling group. And then instance type requirements, you have set up the VPC, the subnets your instances will be launched in. If we're thinking about a 3-tier application, of course, your instances will be in the private subnets and our load balancer in the public subnet. So whatever subnets you select, you have to at least ensure maybe they are private subnets in this case. So I'll select this because I know they are private, but it was for RDS, don't mind me. And then load the balancing. The auto-scaling automatically balances instances across availability zones. So you can say do the best effort or balance only, no need, no major stuff there. Load balancer, this auto-scaling group, will it be attached to a load balancer? So I can, for example, say attached to an existing load balancer, and the target group is the user group, target group that I created before. So I'll skip the lattice settings and the zonal shift because they are not needed. Health check. So right now we have the health checks which are performed by the load balancer in the target group. So you can turn on the load balancing health checks or even turn on the EBS volumes health check and so on. How long does the health check run? The health check period, and then the group size. You have to specify that. So desired capacity, if I launch this auto scaling group, I need like 5 instances to launch. What is the minimum? If it scales down, you can scale down to 2. At most, at all times, 2 instances must be running, and the maximum is 10. So if you get to 10 instances, even if we have 100% traffic coming in, don't do anything, and then you can set up the scaling policy. And I talked about target tracking. So I'm saying the average CPU utilization might stay around 70%. And what is the warm-up period for our instance for it to decide when to scale out? And then the maintenance policy, how is it going to launch or terminate? So is it going to launch an instance before terminating, or terminate an instance, then launch one, and so on? And then you can set up all the additional settings, set up notifications if you want, and then just go ahead and create your auto scaling group. And what happens is it will automatically start updating the capacity to the desired capacity of 5. So if I go to my EC2 dashboard right now, or my EC2 instances, sorry, I should see the auto scaling group trying to launch 5 instances for me. So let me refresh that. You can see all these 5 T2 nanos initializing at the moment being created by my auto scaling group. So there are lots of features you can look in with the auto scaling group and so on. You can, the automatic scaling that is happening, the other policies that I mentioned, you'll find them here. So for example, we have the dynamic scaling policies, target tracking, predictive scaling, or set up a scheduled action in this case. So that wraps it up. Yeah, I have 1 minute to cover the last topic I wanted to, but it shouldn't take long. So I'm requesting 5 more minutes, please. Yeah. So
You have 15. We
that
can
is
give
it
you the
about.
additional 15. Pauline, we can give you the
Oh,
15
thank you.
to complete.
Yeah, thank you so much. So that is basically load balancing and auto scaling and how it works. Now I'm going back to cover. So all the other options, of course, you can find them when you go through the console. I can also share a workshop. You can try your hands-on if you need more information. Yeah, the only thing I want to cover is all over here about outposts. So outposts, what is outpost? With outpost, we have a specific requirement. We want to run some of our applications locally. For example, I have a database which, due to compliance requirements, I cannot host that database in the cloud, but my application servers are in the cloud. I just want a connection to the cloud while running the service on-prem. That is where outposts come in, and you can see outposts extend your VPC and Let me just present. So Outposts extend your VPC infrastructure. How does it work? You're going to host your AWS services on-prem in your data center, and it will be automatically connected to your VPC infrastructure. Why are we doing this? Meet some data residency requirements. So compliance, basically, some of your data has to live on-prem and so on. Or you want to do local data processing. You want to create resources that provide low latency. For example, I'm hosting some machine learning workloads or IoT related stuff, and I want to locally process my data in my on-prem data center, so I can use Outpost for that. So if we look at just finishing this and then I go to the documentation, we are getting the same designed infrastructure like in the AWS data center. How it's going to work, you order a server, which is going to be delivered to you and be put in your on-prem data center. AWS will manage, monitor, and operate those servers for you as if it was in their own regions. And then same APIs, same tools, which are being used with the servers in AWS regions. So you can either choose a rack, order a rack from AWS, or order a specific server. Now, if we take a look at some of the, let me open this link, just looking from the documentation at how it works and some of the services that Outpost gives us. Loading too slow, and I'm always impatient. Let's see. Wow. Let me try a different browser. Okay, Chrome gave up on me. Back to Microsoft Edge. Okay. Seems like my laptop gave up. So I'll just share the link on chat, and then I don't know if there is anyone on the laptop who can share for me. Okay, found a temporary solution for now. Okay, hope you can see my screen from my second laptop. I don't know. Not yet. Is my screen visible?
No, not yet.
No.
No.
Okay. Now it is. Awesome. Backup. Yes, I'm fault tolerant or I'm highly available. I don't know. Okay. So just covering on Outposts. As I mentioned, it's a fully managed service, how it extends the AWS infrastructure and tools to your customers on-prem and so on. Here I'll just take a look. It does not run all the AWS services, okay? So for example, which resources can you run on Outposts? Either EC2 instances. Isaac, I see your hand up.
Apologies. On my end, I can't see your screen. Is it on my end or everyone else on the call?
I
I
don't
think it's
know.
your network.
Maybe.
I see it very clearly on my end.
You can see
Isaac,
the
it's your network. It's your
It's your
network. Me, I
network.
can
Check
see
your
her.
network. I see it
Oh,
so clearly
okay.
on my side.
Okay, let me
Isaac.
just try to log in again. Okay.
Okay, my village people who made my laptop stop working have visited us. Yeah, so uh, resources which run on Outposts, we have the EC2 instances, EKS clusters, ECS, Elastic Container Service, or Kubernetes workloads. So the Elastic Kubernetes Service workloads. And in terms of databases, so we have the Elastic Cache, you can run Amazon RDS databases or Elastic MapReduce clusters. Networking, you can set up your subnets, Route 53, your load balancers, storage supports, EBS and S3, and then the IoT services. So these are the services or the resources which you can launch on Outpost and then just extend that infrastructure to AWS. So if I take a look at the Outpost service on its own, so how it works over here, you are running the AWS infrastructure on-prem. You order from the console. So you select your configuration, which configuration you want, the compute and storage. You order, and then the AWS people will deliver either the rack or the server to your data center, perform the installations for you, and then you can launch EC2 instances or services in your workload, and it has like an integration to the AWS infrastructure or regions. So you have to specify like the availability zones, and that way it has direct connection because it's just like they have brought the AWS infrastructure to your specific yeah, to your specific data centers. So I the hardware specs, you can see like the Outpost rack, what it looks like over there. Standard 42U racks, 80 inches and so on. The services you can run or could be hosts, and the hosts are like servers that you can order. Yep. So you are ordering specific server. You can order a mix of instance types. These are the supported instance types that come available. And then you install that server in your own data center. So you have information about the networking capabilities, that you have the power. So they have like a redundant power network and so on. Security, lockable door if you are ordering a rack, some encryption keys, and the specific facilities that you can get delivered to you. So that is it about Outposts, because just you just have to know about it unless you need the infrastructure in your own data centers is when you'll use it. I have not ordered an Outpost rack, but why do you need that? Local data processing, you still want to run some operations in your data center and you need a connection back to the AWS regions. So here are some FAQs if you want to understand why exactly would you need to, why would you use Outposts instead of operating on a single region. And that is it, yeah, about Outposts. And I'm done. Yeah, I used like 10. But yeah, I blame my village people because if my laptop was still working, I'd be okay. Okay. Thank you so much. If you have any questions, you can bring them coming. And I think over to you, Terence.
Thank you, Junior, for that session. And I really will soon be handing over to Isaac for any questions. Actually, we are open for questions from your end. You can unmute and ask any question. For us, where we are sitting, we hope that you are all signed in on AWS Educate and you are pushing and working on your various badges. By this time, you should be very, very through with the compute badge. Now that with that last presentation and that last instructor-led session by Pauline Jr., we are so done with compute. Isaac, next week, I will be here. I will handle the first session. It will be a knowledge check on what you've gathered so far because we've done compute. So we'll be doing a knowledge check on compute for session 1.
All right.
Once session 1 is over, we'll also have a knowledge check extensively on a pre-knowledge check on storage because our journey starts moving towards storage. Then if time allows, maybe Major Mbadi will be here to start on S3. If time does not allow, he will be pushed to next week, but 1 for him to start us on storage with object storage and S3. Hey, the feedback is, now it's the feedback round. How is it going? Is this is it adding value to your preparation, or are you guys suffering, or are you guys coping, or are you guys surviving, or are you guys thriving? That's all we want to know. We want to check the pulse rate.
So of course, this being on my end, this being detailed, I mean, it's and having educate, it's like a plus in terms of solidifying all the knowledge we are getting. And I think, yeah, we are getting in there. We shall stick there. We shall stick in here. We're not going to run away because the end goal will be for us to sit for the exam at the end of the boot camp. That's like in August or September, somewhere there. But yeah, it's good work and it's the progress is good so far.
We have my friend Jacob. How is this coming on for you?
It's going on well. There are new, at least there are new services that I'm seeing that I didn't see in the previous associate. So it's good. Like there are certain things that are coming up.
Yes, we dig deep. We go broad, we go wide. The volume, the breadth, the length will be all at another level. Felix Fianyeku, over to you. You have your hand up. Felix, if you are speaking, Felix Fianyeku, I do not hear you at all. Maybe you can put your contribution in the chat. Isaac, I don't think I have anything to add. I really want to hand over to you such that you can close it out for us. Huh?
All right, thank you so much, Terence, Pauline, and William. I think we dropped off along the way. So, Terence, from your end, we shall be looking out to getting these recordings for the previous sessions, which we have not yet gotten, so that I can share that in the group with the team.
I think the recordings you need is for last week and this week, and I'm willing to bet Pauline Jr. will do something. Eh?
Great.
As soon as the one for today is published, I'm willing to bet Pauline Jr. will do something because the other one was pre-knowledge check. The other one was pre-knowledge check, so not really necessary, but the knowledge check for next week and maybe pre-knowledge check for next week. We will, of course, we recorded everything. Eh? So we will look into it. I think so far, not so bad. I think we are on track. The people I'm worried about is anybody who is not set up on AWS Educate. Please direct message and reach out to Isaac and Darius and Brenda. They will help you. You know, we are doing a hybrid and blended mode of delivery. So you need Educate to, and also you stand a chance within this timeline that we are doing this thing, you stand a chance of doing all those badges and redeeming the voucher worth 150 USD, which is something good. And with all this support, I think everything will work out well and will ensure that you certify successfully. So if you've not signed up on AWS Educate, any of the user group moderators will be able to direct you appropriately. So do not shy off. We are here to help each other. So we learn together, we suffer together, we survive together, we thrive together, and we also want to pass together. And also we want you to later on share your success on social media like LinkedIn, and let the user group and even we, your trainers, know that you are able to do this with the support of this community. Mark Miro, you have your hand up. Mark.
Hey, hello.
Hello.
Yes, I'm just new to this community. I've heard you talk about the budget and reclaiming something. Can you clarify on that?
With the badges, I think, are you on the WhatsApp? Are you on the WhatsApp by any chance?
No, but I was already on the AWS Educate. And
Okay,
so far,
so if you are on the AWS Educate, there is a promotional period going on. So we have already, today we have wound up on our compute, our coverage of compute. The past 2 weeks we've been working on compute. So on our part, we would wish that you finish the compute related content badge, and we start building up on the storage badge. When all these badges are aggregated together, you stand the chance of redeeming a voucher worth 150 USD. And we are not saying you have to go as per our pace. You can even go faster if that is. But for us, you can join us to study with us together every Saturday.
Oh, I get. I still have like 11 badges now.
Okay. So I think you are, you're a good way towards redeeming that voucher. And as soon as you're ready, you redeem it. But you're always welcome. This is your community. It's our community. And we learn together. We have fun together. We hope we will also pass the exam together.
Yeah, I'll be looking forward to. Thank you.
Okay. I think Isaac